check whether the live stream is working fine? Oh my. Okay, can someone check whether the live stream is yeah, can someone check whether the live stream is working fine? I think it is working fine because I'm able to see it. What I'm going to do is I'm just going to share the link again into the chat.
Yes, sir, it's running.
Yeah, it is going fine, right? Yeah, cool. So now going back to the class. So we were actually learning about pointers, if you remember, right? So we learned about pointers. We learned how we will declare a pointer, how we will assign value to a pointer, how we will access the value of the variable which we are pointing to using the pointer. Then we have learned pointers to pointers. Then we have learned passing pointers to functions, and then we have learned returning pointers from functions. Correct? So those are the things that we have learned. We have learned pointer arithmetic. We have learned array of pointers, pointer to pointer, passing pointers to functions in C, and returning pointers from functions in C. So this, you will be able to return the pointer to the local variable, static variable, and dynamically allocated memory as well. So we have not learned what is dynamically allocated memory. We will learn it slowly. Anyway, so that was the topic. That was it all about pointers. Just a second. Am I sharing my screen?
Okay.
Yeah. Okay.
Sir, the YouTube live stream is running.
Yes, I know. So are you guys looking at the live stream? Okay. So pointer arithmetic, array of pointers, pointer to pointer, then passing pointers to functions in C, and returning the pointers from functions in C. So those were the things that we had learned. And now, before we came to pointers, right, we were learning about structures. So let me go back to structures. Okay. And so structure is a user defined data type. Correct? That is something that we have already learned, and this is the place where we will declare the particular structure variable. Okay, so if we want to declare a particular structure variable, let's say we have a structure called books, and we want to declare the variables book 1, book 2, book 3, we can do it here. Or if you want to declare an array of books, then you can declare that way as well. Okay, so here we have a structure called books, which has the 4 attributes: title, author, subject, and book ID for a particular book. And then we have declared a variable called book. Okay, so this is the identifier to the variable that we have declared. Okay, book. And we know how we will access the members of a structure, right? So when we have multiple members in a structure, of course, definitely if it is just one single member in the structure, then we don't really require that structure. Okay, so structure is used to so we had already taken an example earlier, right, where we had a LibreOffice calc sheet or a spreadsheet where we had the data, say title, author, subject, book ID, and then each row, right, will be an entry in the with the multiple attributes. Okay, so we have already seen how we will access the member variables, right, and this is done using the dot. So book 1 dot author. So for example, here we have a structure called books. Okay, this is the declaration for the structure called books, which has 4 attributes: title, author, subject, and book ID. And then in the main function we have declared 2 books, okay, two variables of the kind structure books, and this is called book 1 and book 2, and then we are going to assign it some value for book 1 title, book 2 book 1 author, book 1 subject, and book 1 book id. And the same way we are assigning some values like book 2 title, book 2 author, book 2 subject, and book 2 book id. Okay, and this is how we will print the content or print the data that is there in the structure. So if you want to access the title of book 1, then you will do it as book 1 dot title. Book 1 is the structure variable of type what? Books. Okay, so struct books book 1 and struct books book 2. Okay, and so you will print book 1 dot title, book 1 dot author, book 1 dot subject, and book 1 dot book id, and the same way for the book 2 also. Okay, and now we were looking at how we will pass the so this is also something that we have already seen. So structures as function arguments. So if we want to pass structure as an argument to the function, okay, so this is an example for the function declaration for a program where you have a structure called books, okay, and here we have a function called print book, which is going to take a book of type struct books, okay, as a parameter to print books, okay, and then you have the definition of the function at the end of the program after the main function. So the function print book has been defined here, which takes book, okay, and then you will print book dot title, book dot author, book dot subject, and book id. So it's just like the same old program that we had earlier seen, right, where we were assigning it some value, C programming and telecom billing and Nuha Ali and Sarah Ali, okay, C programming tutorial and telecom billing tutorial. So that is the one that we had assigned, and now we are going to use a function called print book, and we are going to pass a structure as a function argument, okay, and so we have already declared the function void print book, okay, and we have already defined the function as well, correct, and we have already assigned the values of book 1 and book 2 with the title, author, subject, and book id for both the books. And then what we will do is we will just call the function print book with the variable that we want to print. So we can see that book 1 and book 2 are the two different structure variables of type books, okay. So we will just pass print book book 1 and print book book 2. It will print the entire content. So this is just a call by value, okay. So we were calling the particular structure, I mean we were just passing the structure as a function argument, and this is an example for a call by value. And then we wanted to learn about pointers, okay, and when we wanted to learn about pointers, I stopped here and I told you that we will come back after getting a bit more of idea about what pointers are, right. So now we know that pointer means that it is a variable of a particular type, okay. Let's say the type is integer, and if the pointer is an integer pointer, then that integer pointer will always point to an integer variable, okay. And if it is a floating point variable, then you can use that floating point variable to point to a floating point value, okay, or floating point variable, okay. So you cannot actually use an integer variable to point to a floating point variable, okay. So now let's take a look at pointers to structures. So just like how we have defined int star ptr or char star ptr, or how we have defined float star ptr, okay. Here the type of the pointer is struct books. So you have to define the type of the pointer, and struct is the keyword. So struct you have to always use, okay. Books is the structure variable, structure that we have created. So struct books and star struct pointer, okay. So here we can actually assign the address of book 1 to the struct pointer by writing the statement struct pointer is equal to ampersand book 1. So it is just like how we have learned pointers. The only difference here is that here we are learning it for a structure, okay, and the structure that we had created right now was books, okay, which contain title, author, subject and book ID. Okay, so we will create a pointer to the structure books. So for that, the syntax is you have to write the type of the variable or the type of the pointer that you want to create. So since it's a structure pointer that you want to create, you have to mention struct books. Of course, why books? Because books is the name of the structure that you have created. Correct, right? So books is the name of the structure that you have created, and when you are going to create a pointer to the structure books, then you have to do struct books space the name of the pointer. That over here in this example it is struct underscore pointer, okay, which is a pointer to the structure books. Correct. Now how will you assign the address of a particular structure variable to the structure pointer? So if we have a structure variable called book 1, then we will use ampersand book 1 to assign the address of book 1 to the structure pointer. So struct pointer is equal to ampersand book 1, and to access the so earlier, right, just a second guys. Yeah. Okay, so I'm searching for structure, dot operator and arrow operator. Okay, so here, right, we access the elements of the structure using dot. Say for example, book dot title or book 1 dot title, right? So that was a dot operator that we have used to access the members of a structure. Now when we are going to access the members of a structure using pointer, we cannot use the dot operator. So instead of the dot operator, we will use an arrow operator. It is called a hyphen greater than symbol. Okay, so just a second. Right. So a dot operator. So for example, let's just write a structure. Okay, struct student so let's say int or char roll number 50, then in char name of 50, char father name of 50. So I'm not going to write the whole thing, okay, I'm just writing some mother name, okay, some attributes related to the structure student. Okay, now this is how we will declare. So this is how we will declare the struct student. Okay, and if we want to declare a variable, okay, of a struct student, then what you will do is struct space student 1. Okay, and if you want to access the roll number of student 1, what you will do is student 1 dot roll number. That is how you will access it. So here we have used something called a dot operator. Okay, and how do you create a pointer to struct student? So this is created using struct, the keyword struct space student. Oh, by the way, it is capital STU, okay, because it is case sensitive, and student 1, okay. Oh my goodness, I made a mistake. PTR, stud PTR. Okay, so this is how you will create a pointer to the structure. And how will you access the member variable using a struct pointer? For this one, what you will do is stud pointer, arrow operator, roll number. Okay, and before that, stud pointer, right, has to be initialized with the address of the structure variable we want to assign it to. Okay, so here we will use something called an arrow operator. Now, okay, so yeah, so that is a hyphen greater than symbol to access the members of a structure using pointer. Using pointer to that structure, you must use the arrow operator as follows. Okay, now if we write the same program, right, the print book. So earlier the print book was a function where the function was called by, what is it, called by value or called by reference? What is it? Called by value. Okay, so here we have rewritten, or they have rewritten the program with a pointer or a call by reference. Okay, so this is how we will pass the pointer to a function, and how we will access the variables using the structure pointer. Okay, so here we have a print book function, okay, which is declared, which takes in one parameter of type struct books, and the parameter is a pointer called book. Okay, and everything in this particular program, right, remains the same. So you assign the value using strcpy, using the dot operator, book1 dot title, then book2 dot title, book2 dot author, book2 dot subject, and book2 dot book id, book1 dot book id, and so on, right. So everything remains the same, okay, except the function call. Okay, and the function definition, of course, if the print book function definition has to change, because now we are passing the pointer, and earlier we were using it by the call by value. So over there we could have just used the dot operator to print the book dot title and book dot author, etc. Okay, so here we will call the function print book with the structure variable book1. So we will pass the reference to book1 using ampersand book1, and reference to book2 using ampersand book2. So this is called by reference, and here we are passing the address of book1 and book2 to the structure's formal parameter. So the actual parameter is ampersand book1, the address of book1, okay, and that is stored in book. Okay, now let us take a look at how we will define the function print book. So here struct books star book, okay, or struct books asterisk book, which is actually a pointer called book. And just like how we had done it earlier, instead of using book dot title, right now we will use book arrow operator title, and book arrow operator author, book arrow operator subject, and book arrow operator book id. Okay, so this is how we will write a pointer to function, and how we will pointer to a structure, and how we will pass the pointer to the structure to a function. Okay, so that is it about pointers to structures. And before
Sir?
yes,
The star book stores the address of both book 1 and book 2.
okay, so these are two different calls, right?
Yes, sir.
So which means that print book ampersand book1 is going to pass the address of book1 to books, and once this executes, right, this will return the control back to this particular place, and then this next statement will get executed. So before this next statement gets executed, right, this particular star book will get even deleted from the memory because there is no further scope. Does it make sense?
Yes. Yes, sir.
All right. So just a second. Give me a minute. I'm just reporting some of the comments that are coming in our live stream. Take another 10 seconds. Okay. How can I disable chat completely? Okay, I had actually held the comments for review, so it is okay. Okay, so is that question, who asked that question regarding whether star book will hold
Me,
address?
sir, Ravish.
Ravish, okay. So is that clear, Ravish?
Yes, sir.
Okay, so you have to understand that this is one function call, and the function will return to the same place, and then the next statement will get executed. Okay, so when the next statement print book ampersand book 2 will get executed, it will create a new instance of print book, okay, with ampersand book 2, which means that the address of book 2 is passed as the formal parameter, as the actual parameter to the formal parameter star book. Okay, and then it will access the content of book 2. Okay, now before I tell you the next topic called bit fields, okay, let us just take a look at what is bit field. Okay, so assume that whenever we are working with let me take you to bit fields. Okay, before bit fields we have to learn something called unions also, but I will actually teach you unions after we learn bit fields. So first let me tell you about bit fields. So bit fields, okay, so now so far we were dealing with variables and assigning values to the variables, accessing the variable, maybe storing some content, some data into the variable, accessing that, manipulating that, and such kind of things. Now there could be some conditions, some situations where you may not be actually using the entire byte allocation. Say for example, if I say int x, okay, x is actually a 4-byte variable, right? It takes 4 bytes of storage. So if I say struct unsigned int width validated and unsigned int height validated, then it will actually take 4 bytes each. So that's the idea. But now let us say that over here the width validated. So it is saying that either 0 or it is validated. So not validated meaning that false. Width validated 0 means not width validated. Width validated 1 means it has been validated. Height validated value 0 means false. Height validated value 1 means true. Okay, so if I am going to assign true or false, or just 1 and 0 to this particular variable width validated or height validated, then instead of actually using all the 8 bytes of memory space, okay, since we want to store the value only 0 and 1 in each of the variable, there could be a better way to utilize the memory space in such situations, and that is where we have something called a bit field comes into picture. Just a second. Okay, so here, right, we have unsigned int width validated :1. Okay, so :1, that is actually to tell that the compiler that we are going to use only 1 byte. Okay, I'm sorry, not 1 byte but 1 bit. Okay, we are going to use only 1 bit of storage for this particular variable width validated. So 1 bit means, for sure, it can have only 2 states, which means that it can represent only 2 values, which are 0 and 1. Okay, so this one, right, this is an example for the bit field. So in the above structure, right, it requires 4 bytes of memory space for status variable, but only 2 bytes will be used to store the values. Okay, so let us say that in another way, if I had 32 this kind of member variables in this structure, okay, so if you will use up 32 variables, each one with width of 1 bit, then also the status structure will be will use 4 bytes. So 4 into 32 bits, right? So if we are saying that if we have 32 such variables, then and each variable will use 1 bit, so 32 bits it will be using. So 32 bits divided by 1 byte is equal to or 32 bits divide to convert it into bytes, you will get it as 4 bytes. Okay, and in case if we had 33 variables, okay, then it will allot the next slot of the memory and it will start using 8 bytes. Okay, so it will allot 4 bytes, okay, that is one slot of memory. So if you had 32 variables which are all bit fields of 1 bit each, then you will totally be using 4 bytes for this particular if you had a particular structure variable like which had 32 variables each with 1 bit of bit, okay, with a width of 1 bit. Now if instead of 32 I am going to have 33 variables, then it means that I should be having total of 33 bits assigned, but instead of assigning 32 bits, right, it will assign 4 bytes together. So 4 bytes is 32 bits, and so 4 bytes is assigned to the 32 bits, which is already called 4 bytes. So which will be 4 bytes plus 4 bytes, totaling about 8 bytes. Now again the same way, if you are going to assign one more bit field, right, the 34th variable, it will still be only 8 bytes because that much memory space is available to you. So here, right, is an example of using the structure with the bit field. Okay, so here we have a structure called a simple structure which has a variable called status2, which has width validated and height validated, but those are integer variables. And we have another structure variable whose who has a variable called status2, which are using bit fields. Now if we try to print the size of the status1 and status2, right, the status1 will print it to be 8 bytes because 4 bytes for integer and 4 bytes, 4 plus 4 is 8, and this one it has to assign 4 bytes for the first integer. Now since we are using only 1 bit field, out of the 4 bytes the 31 bits are free. Okay, and since we have one more bit field defined, out of the 31 free bit fields we will use one more bit, one more bit, which means that out of all the 32 bits which have been assigned for status 2, okay, 2 bytes will be used. I mean 2 bits will be used. Okay, so the size will be 8 and 4. So this is the idea of bit field. So bit field means that we will define the width or in bits for the particular variable that we are creating. Okay, so here we have structure unsigned integer age 3. Okay, so which means that you can store up to 3 bits. Okay, so now let's take a look at so that was about bit fields. Okay, so we learned about structures and bit fields, and now let us go back to structures and see whether the topic that we wanted to learn, that is about bit fields, if we are able to understand it. Okay, so we're going back to structures. So here we have a bit field based structure. Okay, that's just how we have seen in the previous place. Okay, so this is a very simple structure with multiple bit field data members. Okay, and you are assigning you create a variable called pack of the type pack struct of struct. Okay, so that was about bit field and structures, and we have learned structures quite well. Now I want to tell you one more topic called unions. Okay, okay, so I have another topic called unions. So a union is very similar to a structure. Okay, a union is very similar to structure. The only difference is that instead of using the struct keyword, you will use the union keyword. Okay, so a union is very similar. I did not say it is the same. Okay, it is very similar to a structure. The when you are going to declare a union data type, okay, which is a user defined data type, you will use the union keyword instead of the struct keyword. Okay, instead of struct struct keyword, you will use the keyword union, and everything else with regards to pointers, with regards to accessing the member variables, declaring the variables, etc., remains the same with structure. Okay, but with one catch. What is the catch? A union will assign only that much space of memory, or that much memory space in the computer memory, which will be the largest, which will be the space that will be occupied by the largest member variable of the union. Okay, so here, right, in this example we have 3 member variables, I, F and str, and we have a union called data. Okay, so we have a union called capital D, data, which has 3 member variables, I, F and string. I is of type integer, F is of type float, and string is of type character of 20. So here, right, int I we know that it is 4 bytes. In integer variable will take 4 bytes and floating will take 8 bytes. So 4 bytes is I and F is 8 bytes. So 4 plus 8, 12, and plus 20. So 12 plus 20, which is 32. So if it would have been a structure instead of union, then this would have taken up 32 bits of storage. Am I right? No, it would have taken 32 bytes of storage. Now, in the case of union, right, the memory occupied by the union will be large enough to hold the largest member of the union. For example, in the above example, okay, data type will occupy 20 bytes of memory space, because that is the maximum space which can be occupied by a character string. So this will be 4, this will be 8, and this will be 20, and I told you if it is a structure instead of union, then this whole thing would have taken up a total of 32 bytes of storage. But since this is a union, this is going to store, this is going to reserve only that much space in the memory that is taken up by the biggest member variable in the union. Okay, so in this one, the biggest member variable in the union is char str20. So it's a string of 20 character spaces, so 20 bytes. So the data type will occupy 20 bytes of memory space, because that is the maximum space which can be occupied by the character string. Are you able to follow what I have tried to tell you? So for example, I'll just copy this particular program, okay, and I'm going to put it in my Emacs, okay. Where is Emacs? Okay. So I'm just going to copy the thing, paste it here, and I'm going to call it as struct. I'm going to call it as struct data, and I'm going to let me save the program. So here I have created a program called size of underscore struct underscore union, where I have two user defined data types. One is called a union and another one is called a struct. Okay, and I'm creating two variables. Okay, say struct data, s data. Okay. So that's the struct data, and then I'm going to print the amount of space used by union data. Okay. Then let us say \t struct data percent is percentage d \n. Okay, so I have size of data and then I have size of s data. So I'm going to print the size of data and s data in two lines, correct? So memory size occupied by union data and struct data. So you can see that it is, I have just copied the same thing, just made the union into a structure, right? So now let me take the terminal. Okay, this is from the previous class, J 2021. Okay, here now GCC size of underscore struct union minus o size of. Okay, so the program has compiled, and let us run the program. Size of struct. Okay, you can see that, as I told you earlier, the union was if it would have been a structured data, right, it would have taken 28 bytes of storage. That is because float and both integer uses 4 bytes. If this was double, right, if this was double and this was also double, right, then it would have been 32 bytes. GCC, or not 32 but 40. Okay, what is the size of double? Let us just print the size of double also. Okay, so printf percentage d I can write it this way also. Okay, Instead of passing a particular variable, I can pass the data type as well. So double uses 4. What about int? Okay, so 4 plus that's 32 plus double is 8, 8 plus 4 12, 12 plus 20 is 12 plus 20 is 32, correct? Then why is the structure coming out to be 40 bytes? Maybe that is the pool of the chunks of data that is assigned to it. Okay, so the main difference that you need to understand is in union it will take the memory space of the largest member variable. Okay, it will take memory space equal to sum of size of all variables. Okay, is that clear, students?
Yes, sir.
Okay, so that was about so that we have learned about structure, struct union, and we also learned something called pit field. Okay, now let me and as I told you earlier, accessing the member variables of the union or the union is also the same as how we will access the member variables of the structure. Okay, so no difference there. Now I want to actually show you one of the assignment problems. So for today, right, I am going to give you one assignment. So this is apart from your lab work which you get every Monday. Okay, so this is in addition to that. Both are introduction to computer programming. So I am going to just give you the assignment. Okay, so this is the assignment 1 for CS101. So you have to create a program which will take in a sentence or which will take in a paragraph as input, and then it will convert it into Pig Latin format. Okay, so the question is, write a program to take an input string in English and convert the string to Pig Latin. Okay, so we have we have something called Pig Latin. So we want to take an English sentence or an English paragraph or an English text and then convert it into Pig Latin. So you can use the function, you may use the function fgetters if you want to get the input, or we have to get spaces also. So you have to do whatever is required to get a sentence or a paragraph as input. And then you can also refer to the page Pig Latin on Wikipedia to understand what it exactly is Pig Latin. So words beginning with the consonant sounds, okay, words beginning with the consonant sounds. So A, E, I, O, U are the vowels, and the other letters are the consonants, correct? So for words that begin with consonant sounds, all letters before the initial vowel are placed at the end of the word sequence. Then AY is added as the following example. So for example, if you have a word called pig, then the P will be moved to the end of the word. So the P has to be rearranged. So instead of pig, it will be IGP. Okay. So P will go at the end, and then you will add AY to the word. So the word pig becomes ICPE, and the word Latin becomes, after moving L to the end of Latin. So L has been moved to the end of Latin. Okay, so atinla, atin, and then you add an ay. So that is in the case of a consonant. Then you have banana is transformed like this. Butler is transformed like this.
Sir, in
Yes.
this banana, I'm little bit confused. How the A has been shifted this and N and A.
What is the confusion?
Sir, like in the first one, pig, the
Ah,
vowel in that particular word has been shifted to the front.
okay. So
But sir, in
let me show you. Oh, okay. So here we have pig, right? So
yes, sir.
it P is the consonant which you have to move. So P has to be moved at the end of IG, right? And P, so it becomes IGP, and then you add AY. And for banana, what you will do is you have to move B, correct? So for that, A and B, AY, correct?
Means we have to just shift the consonant to the last part and then add AY.
Yes, correct.
Okay, sir.
Okay, so this is not about consonant. Okay, so this is very tricky little bit. So for the words that begin with the consonant sounds, all letters before the initial vowels are placed at the end of the word sequence. So these are certain examples. Okay, banana becomes ANANABAY. Butler becomes UTLERBAY. Will becomes ILLW. Okay, and then AY is added. Happy becomes appy hay. Duck becomes day. Me becomes may. Bagel becomes egel bay, and so on. And if you have consonant clusters, okay, so here in this particular example you can see that the second character was always a vowel, correct? It was always a vowel. Now if you have a consonant cluster, say let's say smile, okay, so again you will move the consonant clusters to the end. So when words beginning with consonant clusters, multiple consonants that form one sound, the word is added to the end when speaking or writing. Example, smile becomes I'ls may. Okay, SM is moved at the end and then AY is added. Then string STR is moved and then AY is added. Then for stupid, it has to be ST, because AE IOU. Then trash TR, gloves GL, floor FL, store ST. Got it? And if you have words that begin with vowel sounds, let's say eat, omelette, are, egg, every, I, explain, always, ends, honest. Okay, so here honest, though it starts with H, it's still a sound, honest. The sound is O, so it's a vowel which it starts with. So eat becomes eat a, omelette becomes omelette a. So you have to add y to the end. So if it is a vowel sound that it starts with, then it is left alone and it becomes eat a, omelette a, re, egg a, every a, I a, explain a.
Sir,
Yes.
sir, in the honest one, sir, it ends with AY only, not YAY. And
Yeah,
H is
because see this in this one, right? H is actually considered as a so this is a sound.
consonant.
Okay, so this uses the same rule that we mentioned at the starting.
Consonant one, sir.
Yeah,
Yes, sir.
H is a consonant, so the consonant is moved to the end and then AY is added. So if it starts with an vowel, then YAY is added. Got it?
Yes, sir.
Okay. So that is about the Pig Latin. So I'll send you this PDFs by email, and it is all. By the way, you don't require an email because it's already available on Moodle. Okay, so you can just take a look at the. Just a second, guys. Can someone check whether it's available on Moodle? I think if it's not available, I will just make it available. Just give me a moment.
No, sir.
Yeah, it's not available, right? Yeah, I'll just make it available.
Sir,
Yeah, can you refresh and check whether it is available now on Moodle? Somebody was asking me a question.
Yes, sir. It's
Yeah, it's
available.
available. Okay. So who asked me a question? Somebody asked me, sir.
yes, sir.
Yeah. Go ahead, Krishna.
So
Sir.
in the previous assignment, sir, there was a part of part D, that occurrence one. Sir, I didn't get what we have to do in that.
Okay. Like in the CS101, it's in the lab assignment.
Assignment 7. Yes,
Okay.
sir.
Okay. So in the lab assignment 7, find the occurrence of a character in the string using functions. So the dth one, right? So I will actually.
Yes, sir.
Okay. So you have to find out whether there is any character, say O or B or something in the. So let's just take a look at the.
So in this we have to find the how many times a character has been occurred. That no.
For that we have the count the uppercase, lowercase, and special characters in a string, and then toggle. Yeah. So find occurrence, print all vowel consonant, replace all vowels with star and consonants. Okay, so here, right, you want to actually search for a particular character O. Okay, and so I want to search for I want a character to be searched in this particular sentence. So I have a big sentence with me. Okay, now in that one, O is the character that I want to search for, and I will get the output as hello and world. Okay, so if I have a huge sentence like this and I give O as the input, then the words that will be returned where it will be of, Anup, Jacob, Thomas, then computers, then of again, and then programming. Does it make sense, Krishna?
Yes, sir. Yes,
Okay,
sir.
sure.
Got it.
Okay. So that is it about today's assignment, and so the Pig Latin, right? Submit it by Friday next week. Okay, which is 25th of February. So submit it on 25th February, and yeah, for the assignment, lab assignment 7, it will be on Monday. Okay, so that is it, guys. Do you have any questions?
Sir, for the lab assignment 7, should we write all the questions in one program or 7 different programs, 6 different programs, sir?
You can write it, you can write it both ways. I don't have any problem. You can write
Okay,
it
sir.
as one single program with 7 different modules or 7 different functionalities in one program. So whenever I enter a particular thing, you should ask me, okay, enter the character that you want to search it for. Okay, and so on, and I can and then you know it can print the whole thing. That is one way, or you can write it as 7 different programs. But anyway, you have to write it as functions, etc., because you have to write the flowchart and the algorithm also makes very important things, and that is the reason why I have mentioned in there that you have to so lab assignment 7, at the end I have mentioned that you can draw the flowcharts and write the algorithms for the functions separately. Okay, so in essence, if you look at the submission, right, I have mentioned just one C file. So I think you can you should probably try to write it as one single program. Okay. So since I have mentioned it to be one zip file containing the roll number.c and the roll number.pdf, which contains the algorithm and the flowchart, try to make it as one single program. Is that okay, students?
Yes, sir.
Yes,
Okay,
sir.
sure. Yeah. So, do you have any other questions other than this?
Sir, I have a doubt. Can I share my screen once?
Yes, sure, not a problem. So, what I will do is I will stop presenting. Who is having the doubt and who is going to share the screen?
Sir, me Abdul Akram.
Yeah, go ahead, Abdul Akram.
Sir, in the meanwhile, can you tell me when we'll getting the CT1 grades?
Okay. So I haven't finished correcting it. I'll try to give it this week. Okay.
Okay, sir.
Yeah. Okay, Abdul Akram, we are able to see your screen. Just a second. Oh my goodness. Yeah, we are able to see your screen. Now, can you zoom in a little bit? Can you make it bigger? Okay. So you have a program. Okay. This is for the lab assignment 7. Right, Abdul? Abdul Akram, I think your microphone is muted, and because of that reason we may not be able to hear what you're speaking.
Oh, sorry, sir. It was muted automatically. I don't know why.
Okay, no issues. So were you trying to say something?
Yes, sir.
Okay, go ahead. This is for the
So
lab
when
assignment 7.
when I'm running, yes, sir.
Okay.
So when I'm running this program,
Ah,
so I'm giving some input.
okay. Okay, so this is it's taken the string. This is Akram. Okay.
So here it should wait for the user to enter the character to search, but it's not waiting, sir.
This is because your previous scanf, right? Do you have a scanf
Yes,
before
sir.
line number 159 somewhere?
Sir?
Before line number 159, do you have a scanf somewhere earlier?
Yes, sir. Yes, sir.
Okay.
So I have here to take the input, text input.
Okay, and it is okay. You are escaping the \n from there only. Okay, percentage, then \s, and then you are giving %s. Why do you give address of the string there? Even if you give just s, it should work, right?
Yes, sir. So both will work just
Okay.
idea like that. Both
Okay.
will work. Yes, sir.
And string copy s1 comma s. Where is s1?
So I have declared it globally, sir.
Globally. Okay. Sure. Okay. And then you have length, string length s. Can you run it once again and see what happens?
Yes, sir. It's not waiting, sir.
Yes, it is not waiting. Okay. Just give me a moment. So I'm going to send you a link for that. Okay. So this is from Stack Overflow link. So this is actually saying that your previous input had actually kind of entered this value into the scanf. Can you use maybe fgetters or maybe something other than scanf for scanning your entire string, Akram?
Sir, I don't know about them, sir. I need to learn about them first.
You can.
I'll try after learning them, sir.
No, I'll show you. So you can use man getfs. Okay. So there's something called fgetters, which you can use to.
Should I stop presenting?
No need. Oh, am I? Okay. Wait. I'll present. Yeah, you can stop presenting. Okay. So if you use getfs, right, you can use man fgetters, and that will tell you how to, use fgetters. So before that, let me open the program that I must have written in the past time. Just a second. Okay. So I have yeah. So you can use this function. Can you try doing this, Akram?
Sir, are you sharing screen? Nothing is visible, sir.
Oh, am I not sharing my screen now? Oh, I'm sorry. I had to select the screen sharing option. Okay. Now is it visible? So you can try
Yes,
using
sir.
this particular function, fgetters. So here you have a string name and the buffer length, and from where do you want to get the input, from the standard input. Okay.
So the name is variable in which we want to store, sir. And
Yes,
the next one
yes.
is size.
Yes.
And what stdin is?
That's the
Input.
standard input. So where do you want to read
Yeah,
the
okay, sir.
content from? Where do you want to get the data from?
So should I replace it with the first scanf or both the scanf I use?
Just for the first scanf.
Okay, sir. I'll try that.
Okay, and just take a look at it, and if it is not working, get back to me.
Okay, sir.
Are you going to try it now?
Yes, sir. I'll try it.
Okay, then
so
I'll-
next class is starting. I'll
Next
try and
class
text
is
you, sir.
starting.
Yes, sir.
Okay,
2:35.
yeah. So then you try that out and let me know. Okay.
Yes,
So
sir.
I'll stop presenting and I'll leave. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, sir.